Hello students, welcome to the first video of this new playlist. In this playlist, I will upload solution video of each of the question of the most recent past paper of Physics Unit 2, which is the October 2024 Physics Unit 2 paper. So this is the first video of this playlist. So in this video, we will discuss the multiple choice questions. That is section A of this paper. So let's get started with section A. So at first, the multiple choice question number 1. Okay, here the question says, which of the following describes light intensity? Light intensity, it is basically I. So intensity, we know that I intensity equals to power over the area, right? So which of the following options describes the intensity best? The energy of light incident on a surface per unit area? No, it's not the energy. Option B, the power of light incident on a surface per unit area? Exactly. So here B is the answer. What about the rest? C, the total energy output of a light source? No. The total power output of a light source? Never. No. So the answer for the first MCQ, it is the power of light incident on a surface per unit area. Option B is the answer. Fine. Okay. Next is multiple choice question number 2. So here the question says light from a discharge tube is viewed through a diffraction grating. An emission line spectrum is observed. An emission line spectrum. Okay. Which of the following explains how electrons in the discharge tube produce the emission line spectrum? Okay. So we know that emission line spectrum, it is seen when an electron is de-excited, right? That is, de-excitation means it will release energy in form of photons and it will get to a lower energy level from a higher energy level. Okay, so which of the option is related to that concept? Option A, excited electrons moves to higher energy levels and absorb photons? No. Option B, excited electrons move to higher energy levels and emit photons. An electron, when it gets excited, it will not emit photons, it will absorb photons. So definitely this is not, and this is not related to the concept of the question, right? Option C, excited electrons move to lower energy levels and absorb photons. No, if electrons move to a lower energy level, then it will release energy, that is, it will emit photons. So it will not absorb photons. So option C is not the possible answer. Only the possible one is D. So what does D say? Excited electrons move to lower energy levels and emit photons. Exactly. When the excitation occurs, electrons release energy in form of photons and they get to a lower energy level from a higher energy level. So the answer is D. Fine. Okay, next is multiple choice question number 3. A student stands a distance d from a wall. She makes a loud sound. She hears the echo of the sound from the wall after a time t. Okay. Which of the following expressions gives the speed of the sound wave? Okay. So we know that the formula for distance s equals to v times t, right? So they asked for the speed of the sound wave, so v equals to s over t. Okay, so basically the time here, this time it is the time required for the sound. Let's say from here the sound has been produced, so that time t, it is basically the time required for the sound to travel this distance d and then going back and again reaching the initial point. So there is echo basically, right? So this is the total time t. So in this time the distance traveled is twice of d and total time is t. So v equals to 2d over t. The distance is d, So 2d over t definitely. So here the option is A. Option A is the answer for question number 3. Fine. Okay. Next is a multiple choice question number 4. Okay. So here the question says a displacement time graph for a point on the surface of a water wave is shown. So this is the displacement time graph. Which of the following expressions gives the frequency of the wave in hertz? Okay, frequency. So to get the frequency, we need the time period from this graph. So this is the displacement time graph. So let's take the reading for time period. Okay, so consider this point. If I draw a dotted line, look, have a look. Let's consider the time required. You don't need to write a dotted line. Look, time period is the time required for a complete wave to the time required for a wave to complete its one oscillation. So this starts from 0.1, right? 0.1, and it is ending the complete cycle, right? It is at 0.7. So 0.1 to 0.7. So the time period, it is 0.7 minus 0.1, that is 0.6 second. We got the time period. So the frequency, we know that the relationship between frequency and time period, it is f equals to 1 over capital T. So frequency is 1 over 0.6. So which one is the of the option is related to that one? This is nothing but option B. 1 over 0.7 minus 0.1, it is basically 0.6. So option B is the answer, and this is the frequency. This is the expression for the frequency of the water wave. Fine. Okay, next is multiple choice question number 5. Okay, so here the question says a current in a wire causes the temperature of the wire to increase. Which row of the table describes the changes to the wire as the temperature increases? Okay, so the first row, the first column, it says amplitude of lattice vibrations in the wire, and the second column, it says resistance of the wire. Okay, for what reason the temperature increases? Okay, so lattice vibrations and resistance. Okay, so temperature of wire increases when the lattice vibration, okay, if the temperature of the wire is increased, then the lattice vibrations will increase and the resistance will also increase, right? Because as the vibrations increases, there will be more number of collisions happening between the lattice and the electrons, flowing electrons, and therefore these those vibrating lattice will put more obstruction to the flow of electrons. Okay, therefore resistance will get increased as the lattice vibration increases. That's why we can say that amplitude of lattice vibrations in the wire increases, and also the resistance will increase. So the option D is the answer in this case. Fine. Okay, next is question number 6 of the paper. So here the question says the circuit shown includes a thermistor. Okay, the temperature of the thermistor increases. Okay, which row of the table shows how the readings on the ammeter and voltmeter change? Okay, so if let's consider, like, if the temperature of the thermistor increases, then what will happen? The resistance of the thermistor will decrease. So this is basically the thermistor. So if its temperature increases, its resistance will decrease. And since the fixed resistor, this is the fixed resistor, this fixed resistor is in series with the thermistor, so as the resistance of the thermistor decreases, the PD across the thermistor will decrease. Therefore the PD across the fixed resistor will increase because the EMF is constant, right? Because in series circuit we know that the PD across the thermistor plus the PD across the fixed resistor, this is equals to EMF. So if the PD across the thermistor increases, if the PD across the thermistor decreases, because as the temperature of the thermistor increases, its resistance decreases, therefore PD across it will decrease. Therefore PD across the fixed resistor it will increase. So voltmeter reading will increase. And what will happen to the emitter reading? Since the fixed resistor has constant resistance R and the resistance of the thermistor it is decreasing, so total resistance of the circuit is decreasing, therefore current will increase. That means emitter reading will increase, voltmeter reading will also increase. I will increase as total resistance is decreasing, voltmeter reading will also increase. So which of the option describes that? Option D. Both emitter reading and voltmeter reading will increase. That's it. Okay, next is question number 7. MCQ, multiple choice question number 7 of the paper. So here the question says particle X of mass m is moving with velocity v and has a de Broglie wavelength lambda. Okay, particle Y has a de Broglie wavelength 0.25 lambda. Which row of the table could give the mass and velocity of the particle Y? Okay, so the particle X has mass m and its velocity is v. So lambda equals to h over mv, right? This is for particle X. Okay, and for particle Y, let's say lambda y, it is given as, okay, the particle Y has a de Broglie wavelength of 0.25 lambda. Okay, 0.25 of lambda. Okay, so if you consider 0.25 lambda, now we have to find out the mass and velocity of the particle Y. So 0.25 lambda, look. So which of the combination of mass and velocity will give 0.25 lambda? Look, lambda equals to h over mv, right? So 0.25 lambda, it is basically 1 over 4 times h over mv. So which of the combination will give 4 mv in the denominator? This is nothing but this one. Look, option B, half of m times 8v. So half of m is 0.5 m. So if you consider this option B as the answer, then you will get lambda of the particle Y, it is h over mv. Mass is half of m, 0.5 m times 8v. So that would give you h over 4v, 4 mv, right? Which is exactly that one. So option B is the answer for question number 7. Fine. Okay, next is multiple choice question number 8. Okay, so in multiple choice question number 8, the question says a student connects 4 resistors between point X and Y as shown. So there are 4 resistors between X and Y. Which of the following expressions gives the total resistance in ohms between X and Y? Okay, before watching the options, see the circuit. Okay, see the pattern. Look, so this is 15 ohm resistor. It is in series with this parallel combination, right? So 15. So for this parallel combination, the total resistance is 1 over 7 plus 1 over 18 equals to 1 over R, right? So 1 over 7 plus 1 over 18, this is basically 25 over 26. So 1 over R equals to 25 over 126. Therefore, R equals to 126 over 25 ohm. Okay. So this is the resistance of the parallel combination, right? And this parallel combination is in series with this 15 ohm resistor. So 15 plus this R and then 4 ohm resistor. Basically, we can see that on this loop there are no resistors. That means all the current will start to flow through this pathway, because the current will always follow the way along which there are no resistance, along the way which has no obstruction. So that's why the current will follow this way, and 4 ohm resistor will have no effect on the flow of current. Okay, so we have to ignore 4 ohm resistor here. So which one would be the perfect answer here? Look, this one, option C, because it says 15 plus R. So R is basically the resistance, the total resistance of the parallel combination, which is 1 over the sum of the two resistors, sum of the reciprocal of the two resistors. So this is option C. So that's the answer for MCQ number 8. Fine. Okay, next is multiple choice question number 9. Okay, here the question says a wave is moving along a length of string in the direction shown. These are the 2 points on the wave. So F and G are 2 points on the string. Which row of the table describes the movement of F and G as one complete wave passes? Okay, so as one complete wave passes along this direction, okay, then how the movement of point F and G would be? Look, consider, we know that wave is a way of transfer of energy through a medium where the particles of the medium will oscillate about their position but are not displaced permanently. That means these points F and G, they will not be moving this way on the direction, along the direction of wave travel, right? They will remain at their position, okay, but they will just oscillate about their position. That means they will either move up or down. Okay, now consider, like, as the wave passes along this way to the right, the previous part of the wave, okay, the previous part of the wave, we have to consider the previous part of the wave. Look, it is basically like this, isn't it? It will be like this, the previous part of the wave. Okay, so that means as the wave progresses to the right side, to the right, okay, point F, it will move down, because the previous part, it is basically lower, isn't it? It is lower point, and it will get to the minimum point, so it will go down. F will go down and then up, right? And then up. It will go down and then up, and then will reach maximum. So is it a complete wave? No. This point to that point, this is complete wave. So that means it is going down, okay, then going up, and then again will go down, then again going down. So first down, then up, then again down. You have to consider a complete cycle. So this point to that point, it's not complete. This point to that point, it's basically a complete cycle. That is 2 pi radian. Okay, 2 pi radian. So we got F should go down, then it will go up, and then again down. What about for point G? For point G, look at the previous part of the wave. It's basically upper amplitude, right? So that means G, it will move up, okay, then it will move down, then it will move down. Look, it's moving down, then it will reach minimum point, and then again it will move up as it moves along that way, okay, then up. Basically the point G is not moving to the left direction, or it's not moving to the right direction. Point G, it's remaining as it's at its own position, but the previous part of the wave, it is progressing to the right side, okay. So as it progresses to the right side, point G will move up and then move down and then again up. For point F, it will move down, then up, then again down. So which option of these folds is describes this best? Down. For F, it should be down, then up, then down. Okay, definitely A, B not correct. So C. C goes, F goes down, then up, then down. Yes. And G goes up, then down, then down, then up. Yeah, exactly. So option C is the answer. For MCQ number 9, C, option C is the answer. So in this case, we have to just consider the property of wave, that as a wave passes through a medium, it will just make the particles oscillate about their positions, not the particles will get displaced. Okay, fine. Okay, next is the MCQ number 10, the last MCQ, multiple choice question of the paper. Here the question says the circuit shows a cell connected to two resistors. The cell has negligible internal resistance. Which of the following expressions gives the power in watts transferred by the 20 ohm resistor? Okay, so 20 ohm resistor, the power of the 20 ohm resistor, it is equals to what? P equals to the PD across the resistor, that is V, times I. Okay, so PD across the 20 ohm resistor, do we know this? Basically we don't know this. Do we know the current? We don't know the current also. Okay, so in this case, okay, let's have a look on the options. Okay, so we have to consider this formula definitely, P equals to VI. So let's use the potential divider circuit equation. So for potential divider equation circuit, okay, we know that the ratio of PD and resistance, right? The ratio of PD and resistance will be equal for each of the resistors, right? So the PD across the 20 ohm resistor, let's say this is V. So V over 20, its resistance is 20, equals to the total EMF, the total PD, it is 1.5, that is the EMF, over 20 plus 30, the total resistance. Okay, so we got the V equals to the PD across the 20 ohm resistor, it is 1.5 times 20 over 20 plus 30. So I have just used the potential divider circuit equation to find the PD across the 20 ohm resistor. Okay, now the current I equals to V over R, right? I equals to V over R. So here the total EMF is 1.5 over the total resistance is 20 plus 30. So 1.5 times 20 over 20 plus 30 times 1.5 over 20 plus 30. Which option is similar to that? 1.5 times 20 over 20 plus 30 times 1.5 over 20 plus 30. So basically option C, nothing but option C. So that's the answer for multiple choice question number 10. Fine.